All right, guys. Let's go ahead and jump in and get started. So 1.4, we're actually going to take the absolute value equation that you guys were working on last class, and we're going to actually start solving them. Okay, so last class what we did was transform them. We took that V shape and we shifted it around, up, down, we flipped it over, all that kind of stuff. What we're going to be doing today is actually solving for X. Okay, so when it says how can you solve an absolute value equation, when it says solve, by the time you're finished, you should be able to tell me what X equals. All right, what you're going to learn today is that most absolute value equations have two solutions, and we're going to talk about why that's the case. So first, what does absolute value mean? We talked about this a little bit last class with the absolute value function. When you're asked to find the absolute value of a number, we're looking for the distance from 0. Okay, so when I'm being asked to find the absolute value of something, I'm looking for how far is that value from 0. So for example, y equals absolute value of 4. So when you see the absolute value bars, you're saying how far is 4 away from 0. So on a number line, how many spaces would you have to go to get from 4 to 0? 4. So the absolute value of 4 is 4. Okay, what if I asked you guys for the absolute value of -5? So we're saying how far is -5 from 0? 5. Okay. Remember, if we're talking about how far, I'm asking you guys for a distance. Distance is not negative. All right? So basically what we're going to do is whatever's inside the absolute value is always going to come out as a negative, as a positive, because we're talking about distance. We're talking about how far it is away from 0. Are we okay with the concept of absolute value? Okay. So for the first few problems, I'm going to use a number line to hopefully give you a visual for what we're solving. And then we'll get into the algebra on how to actually solve these equations. So for the first one, we're going to have a starting point of absolute value of X. So this is our start. And we're going to start at 0 because we're talking about the distance from 0. So I want you guys to put a box on the 0. That's our starting point. Okay. And remember, absolute value is a distance. Look up here at the screen. Absolute value is a distance. So how far am I needing to travel? I need to travel a distance of 3. 3 is my distance. So from my starting box, I'm going to travel a distance of 3. 1, 2, 3. There's my solution. But is that the only direction I can go a distance of 3? I could also go 1, 2, 3. And have a 3 back here as well. So now I have two solutions. X equals -3 and +3. Again, this up here, this is my distance of 3. That's what the arrows represent. The dots down here, those are my solutions. Okay. Does that make sense? Are you guys okay with me so far? Let's try another one. What's different on number 2? The start is, okay, so we talked about this a little bit last time. You're right. The start's not going to be in the same place. In the absolute value, guys, y'all remember how we talked about H was inside the absolute value? And what did H stand for? Horizontal, but it's a liar. It goes the opposite direction. So what is this actually telling me I need to start? This is our starting point, but it's H, so it's a liar. So I actually am not going to start at 0. I'm going to start at -1. So we're going to go the opposite. I'm going to put a box on the -1. That's my starting point. Okay, remember, this is not really a positive one. It's technically a -1. So we're going to go the opposite way. We get so far? Okay. How far do I need to travel from my starting point? 3. This is our distance over here, just like it was last time. So from our starting point, we're going to go 1, 2, 3 this way. And 1, 2, 3 back this way. So what are my two solutions? Negative 4 and 2. Are you guys catching on okay? Okay. Let's check number 3. Let's see if we got it. So if it's absolute value of x plus 5, where's it telling me to start?
-5.
Good, we're going to start at -5, right over here. Again, x plus 5 is our starting point, but it's not a positive 5, it's a negative 5, right? Okay, what's our distance? Where are we going? Distance of 2. So I'm going to go from here 2 to the right and 2 back to the left. So my solutions are -7 and -3. Does it make sense why we are having two answers? Yeah? Most absolute value equations will have two answers. Not always, but most of the time. I'm going to show you guys some examples today where you may only have one solution, and then there's actually some other times where you have no solution at all. But most of your absolute value equations will have two solutions. Alright, so let's discuss to make sure that everybody's on the same page, right? So in number 4, solutions are 8 and 18. So then you guys told me the starting point has to be halfway between the two, right? It needs to be in the middle, so where's our starting point? Starting point is at 13. Okay? So then what do I know from 13 to 18? What is that? 5. And from 13 back to 8, what's that?
5.
All right, so if I'm writing the equation, it's going to have to look something like this guy, right? And we just need to figure out what numbers we've got to put in there. Yeah?
Well, if 5's our distance,
Okay, where should it go? If 5 is our distance, where does it need to go?
equals 5.
Equals 5. Okay, and then we have our x here, and then it's x going to be what? X
Plus 13.
Why is it minus 13? 13 minus is right. It's a liar. Yeah, this is a positive 13 here, so when it goes into the equation, it's going to look the opposite. All right, did you guys kind of follow me? Are we okay? Making sense kind of how to work backwards? If you can work it backwards, then I think you really kind of understand the idea or the concept. We doing okay?
How did you figure out 13 as our starting point?
How did we figure out 13? It's in the very middle of 8 and 18. Right, so the starting point has to be the midpoint of those two solutions. All right, next problem is actually a word problem application of how would absolute value actually be applied in a real world situation. So, in a cheerleading competition, the minimum length of a routine is 4 minutes. Minimum is 4 minutes. The maximum length is 5 minutes. Maximum is 5 minutes. So if we think about in a cheerleading routine, the routine can be anywhere from 4 minutes all the way up to 5 minutes, right? 4 would be the minimum and 5 would be the maximum. Are y'all visualizing this okay? Okay, so what are 4 and 5 in relationship to the whole problem? Those are our solutions. That's the minimum and the maximum, right? Just like on the last problem, 8 was the minimum value, 18 was the maximum value. Same idea here. So let's draw ourselves a number line. And what we're trying to do is write an absolute value equation. So we're going to work this just like we worked the last one, with the 4 and the 5 being the solutions. So 4 is a solution, and 5 is a solution. What's our starting point going to be? 4.5, 4.5. Good. So I'm going to draw that box on the 4.5. That's our starting point. Okay. So then what's our distance? How far is that? 0.5. Good. And then same thing back this direction. 0.5. Go with me? Let's write an equation then. Absolute value and then equals So we have an x here. What do we have here? Minus 4.5 equals 0.5. Do you see how the number line is relating to the equation? Okay. Do we understand why we have two solutions? Because we're talking distance, right? From a starting point, I can go this way or this way, and I'm going to get two different answers. Okay. So from this point on, our number line isn't necessarily going to work every single time because we're adding like more numbers into the equation. So the number line has to work with a very simple situation, like those first few equations I gave you. So we're going to kind of relate it to the number line to the algebra now. Okay? So if this is my starting point, think about this being the number line right here. My starting point would be here in the middle. So we're going to put the whole thing, the y plus 2. But no absolute value, just the guts, just the middle. Okay? Now what's my distance? How far do I need to travel? My distance is 8. I should travel a distance of 8. And when I go this direction, we start adding direction. We start talking about direction. That's where we put our signs on it. So when I go to the right, right would be to the positive direction. And then when I go back to the left, that would be to the negative direction. So I'm going to come back to the left this way, and this would be a negative 8. Okay, kind of looks like the number line. Yeah, can y'all kind of see the number line on there? Yeah. All right, what we're going to do is we're going to actually create ourselves two different equations. So we're going to take the guts, and we're going to make it equal to the positive 8. And we're going to take those same guts, y plus 2, and we're going to make it equal to a negative 8. Okay, somebody asked earlier why a y instead of an x. It's just another variable. Okay, all we're doing is solving for whatever variable is there. Do you guys remember how to solve this kind of an equation? Hopefully we're trying to get the y by itself, which means I need to get rid of the 2. So we're going to subtract 2 on both sides. So then y equals a negative 8 plus a negative 2? A negative 10. Good. Same idea over here. Y plus 2 equals 8. Again, subtract 2 on both sides, and we're going to y equals 8 minus 2, or 8 plus a negative 2 is 6. Okay. So I have questions so far. Are we doing okay? Yeah? Doing okay? I want to show you guys how you can check these. It's an equation. Every equation is checkable. So what we're going to do to check it is we're going to take that negative 10, and we're going to put it back in here in place of the y in the equation. And we're going to process that math. What is negative 10 plus 2? It would be negative 8. Now that's in the absolute value bar, so now I'm asking how far is negative 8 from 0? It's 8 spaces away. I got an 8 on the left, and look at that, I got an 8 on the right. So do the two sides of the equation equal? Are they the same? Okay, the negative 10 is a correct answer. All right, let's try it again with 6. Put a 6 in place of y. What is 6 plus 2? 8. What is the absolute value of 8? 8. Does 8 equal 8? Then this one also checks out. Does that make sense how to plug it back in to check it? We're going to do that some more, and that actually comes into play at the very end of the lesson as well. All right. Now we're going straight up algebra. So no more number line. Again, the number line doesn't work when we start putting all the numbers in. So what we're going to do is take the guts. We're going to go this way, and we're going to go this way. Remember, when we go this way, we're going to the positive, and when we're going this way, we're going to the negative? Can I go to a negative 0?
No.
Is that really a thing? No. So in this particular case, remember, we're looking for the distance from 0. What is my distance? 0. So I'm going 0 from 0, which means I'm only going one place, where I am, right? I'm not moving left or right at all. I don't have to travel a distance. Do y'all follow me? Okay, so this is one of the few situations where we're only going to have one solution, one equation, this guy over here. So we're going to take that 3r plus 12. We're going to set it equal to the only 0 we have. And we're going to solve that equation. What do I need to do to get r by itself? Good. I do need to subtract the 12 first. Those will cancel, and 3r equals a negative 12. And then what? Good. Divide both sides by 3. Those divide out, and r equals a negative 4. Again, check it. Take that negative 4. Put it in place of the r. 3 times negative 4. Negative 12. What's negative 12 plus 12? 0. And the absolute value of 0 is 0. Making sense how to check it? Okay. So again, one of the situations where you're only going to have one solution. All right. Come on down here. Number 8. Absolute value is a, what was this number representing in the problem? Remember, the right side of the equation was always our distance, right? When we were doing our number line, we were going distance. Anybody see a problem with that for number 8? It's a negative. Can we have a negative distance? Can you go a negative 4 miles? Can you go a negative 4 inches? Okay, distance cannot be negative. So, this is actually a nice, easy problem. This is our distance. Cannot be negative, because regardless of what number I pick and I put in here, I process through the math, and when I do absolute value of that, remember absolute value is a distance. There's no way that I can get a distance of negative 4. Distance cannot be negative, so no solution. So if you see your absolute value and it's equal to a negative, remember that negative is a distance, that can't be, so those equations will have no solution. Everybody okay so far? Okay, so I've given you lots of situations where we've had 2 solutions, a situation where we only had 1 solution, and then a situation where we had no solution. We feeling okay? All right. Take a look at number 9. What's different about number 9? Other than the fact that it's red on mine. Think maybe there's no solution? What are you thinking? No solution. There is a negative 3 over here. However, on the left side of the equation, I have absolute value, and then I also have a minus 9, right? We haven't done anything when there's been more than just the absolute value on the left side of the equation. So before I can determine if this is no solution, I need to get the absolute value completely by itself. So I'm going to try to get this chunk of the equation isolated. I want it all by itself. So I need to get rid of anything else that's on the left side of the equation. So I need to get rid of the negative 9 by adding 9 to both sides. So let's do that first, and then we'll be able to see if it's no solution. So plus 9, plus 9. Those are going to cancel. I have absolute value of 3x minus 6 is equal to 6. Is it no solution? No, because now I have a positive over there. All right, so from this point, this is where we can take the guts, the 3x minus 6, and we're going to go a direction of 6, distance of 6 in both directions. Remember, when I go to the right, it's a positive 6. When I go to the left, we add the distance or the direction, so that makes it a negative 6. Basically, you're just going to take that number both times. You're going to make one positive and one negative. So that gives us our 2 equations. So I have 3x minus 6 equals 6. And over here, 3x minus 6 equals negative 6. What do I need to do over here to get x by itself? Add 6. Add 6. Those 6's will cancel out. equals negative 6 plus 6 over here is 0. Totally fine that it's 0. We need to finish solving the equation. How do I finish getting x by itself here? Divide both sides by 3. So I'm going to squeeze that in down here. Divide by 3. Divide by 3. The 3's cancel, and x equals, what is 0 divided by anything? 0. So x equals 0 is totally fine as a solution. Right, over here, same thing. Add 6. Add 6. But this time I have a positive 6 plus 6. So we get 12. Divide by 3. Divide by 3. So this time x equals 4. Questions? Make sense okay? All right, so for my people who like to see it in words, you want to see step by step, what are we doing? Tell me, number 9, what did we do first? What was the first thing we had to do to start this problem?
Isolate the absolute value.
Good. Isolate, what does isolate mean? Get it by itself. Isolate the absolute value. We want to get that absolute value completely by itself on one side of the equation. So that is step 1. That's what we were doing from here to here in the light blue. So now what do I do? After I isolate the absolute value, what do we do? What did I do from here to here? There's no like special words for it or anything. Just explain, what did I do? We split it up, right? We separated it. We made 2 equations. Yeah? Okay. Remember, we do not use the absolute value when we split it up or make the 2 equations. So you can say split in 2. Don't use absolute value. And then I'm also going to put on there plus and minus. Because remember, we're going to do a plus distance on one side and then minus distance on the other side. Does that make sense? Okay. After I split it into 2 equations, what did we do? So from the orange to the blues, what did I do?
Solve the equation.
We just solve each equation. That's it. So our last step is to solve each equation. All right. Let's use those steps, and we're going to try to go through and work probably 2 more equations before we head out. Okay. I'm not going to do number 12. Number 12 and number 13 are kind of a repeat of one another. So to save us a little time, we're going to do 10 and 11. Take a break. Come back and we'll do number 13. We got to do 14. So let's see how far we can get. So let's use the steps we just wrote down to do number 10. So what was my first step? Isolate the absolute value. So this is my absolute value right here. I need to get it by itself. So what do I need to get rid of? I got to get rid of the 10 and the 3, but I get rid of the 10 first. So let's go minus 10, minus 10. So we're doing minus 10 on both sides. So now I have 3 absolute value of 2x plus 5 equals 27. Now, what's going on between the 3 and the absolute value? When a number is squished right up next to something like that, what operation does that indicate? That is multiplication. So how do I undo multiplying that 3? We divide. So we're going to divide both sides by 3. And we're dividing the side by 3. So these cancel. It does not affect inside the absolute value bars. Divide by 3. So now I have absolute value of 2x plus 5 equals 9. All right, that was the isolate part. What's step number 2? Split it up. Okay, so we're going to isolate, then we're going to split. So take the guts, 2x plus 5. We're going to make it equal to positive 9. And then over here, we're going to go 2x plus 5 equal to a negative 9. You okay? Now solve each one of those equations. So I need to get rid of the positive 5, so minus 5, 2x equals a negative 14. Divide by 2, x equals negative 7. We doing okay? Again over here, minus 5. This time 2x is going to equal 4. Divide by 2, x equals 2. Any questions? Let's try number 11 then. Number 11, what's my first step? Isolate. First step is to isolate. Here's my absolute value. Let's get it by itself. So what do I need to get rid of? I need to get rid of the negative 5, and then we'll talk about this guy. Let's get rid of that negative 5 first. That one's pretty obvious, right? Sitting in front of the equation, got to get rid of the negative 5. So I'm going to do plus 5. Let's get rid of that negative 5. So that's going to go away. There is still a negative sitting in front of the absolute value. So it's negative. Absolute value of d over 3 is equal to negative 3. Okay. What is that number? If there's not a number there, what's it understood to be? It is understood to be a 1. All right, so that's like multiplying this absolute value by a negative 1. Well, how do I undo multiply by a negative 1? We would want to divide. So we're going to divide by a negative 1, divide by a negative 1.
That one you divide the negative 5.
Right, so the negative 5 is not getting multiplied. It's being subtracted because of this guy right here. Because there's space in between the negative. There's an operation between the negative and the absolute value. Good question. All right, so our negative 1s are going to cancel out over here. I'm going to write this over here so I have space. D over 3 in the absolute value bars is equal to negative 3 divided by negative 1 would just be 3. Did that work okay? Okay. So d over 3 is equal to 3. Absolute value of d over 3 is equal to 3. Now we're ready to separate. We got the absolute value isolated. Now let's make our two equations. So I have d over 3 without the absolute value bars is equal to a positive 3. And then over here, d over 3 is equal to a negative 3. Yeah. I've been saying d over 3, but what operation is that really do? What is that?
Division.
That's division. How do we undo division? What's the opposite? Multiplication. So the way I'm going to undo d divided by 3 is to multiply by 3 on both sides. My 3's over here will divide each other out, and d equals negative 3 times 3 is negative 9. Same thing over here. We have d divided by 3, so I undo division with multiplication, so multiply by 3 on both sides. Your 3's divide out, and d over here is a positive 9. How are we doing? Any questions? Are we doing okay? Okay. Let's go ahead and hit number 13. Because then when we come back, all you guys will need to do is work on your homework and then for the last few minutes, I'll do number 14. Can we do that? Let's go ahead and get number 13 done. So then you guys have basically the rest of the time before we leave for lunch to work on your homework. And then when you come back, you pretty much have all that time to work on your homework. Is that a deal? Is that okay? What is different about problem number 13 versus what we've seen today? There's two absolute values, okay? So we're going to focus this as one being our absolute value and the other one being our distance. So our absolute value has always been on the left, so we're going to call this the absolute value, okay? This guy is our absolute value. We're going to call this guy over here our distance. Good so far? Are we okay? 3 steps. What's our first step? Isolate the absolute value. Is the absolute value over here all by itself on one side of the equation? Mm-hmm. Yes. So step number 1 is already done for us. What is step number 2? This is where we separate. So take the guts, p plus 4, and we're going to go this way, our distance, and we're going to go this way, our distance. Now what was our distance? Our distance is this thing right here. We're going to take the guts out again, so not using the absolute value, and we're going to go a positive p minus 2. Okay. And we're going to go a negative p minus 2. So just like if it had been just one number, remember we write that number down on both sides. The right side's the positive one, the left side's the negative one. So I did the same thing. I took what our distance was, even though it's not just a number, I wrote it down twice. We did the right one as the positive one, the left one as the negative one. You guys with me so far? Okay. So these are our the middle part right here. So we're going to have p plus 4 is equal to positive p minus 2 is just p minus 2. Okay, so there's that equation. Then I'm going to cover here p plus 4 is equal to a negative p minus 2. So p plus 4 is equal to. Now what can I do with that negative that's sitting in front of a set of parentheses? I can distribute it. It is multiplication, and because these are parentheses, I can distribute or multiply into the parentheses. Does that sound familiar? Okay, so if you had something like 3 parentheses x plus 5, you take that 3 and you multiply it to the x and you multiply it to the 5. Does that sound familiar? Yeah, we're just doing the same thing only with a negative, which is technically a negative 1, right? So negative 1 times p is negative p. Negative 1 times negative 2 is positive 2. Now let's solve both of those equations. We haven't had one today that's had multiple variables, but anytime you have more than one of the same variable, you need to get the variables on one side and the numbers on the other. Most of the time, I think y'all are familiar with variables to the left, numbers to the right. It really doesn't matter, but if you've kind of gotten into that pattern, we'll just stick with that for now. Okay? So I'm going to get my p's on the left, my numbers on the right. So how do I get this p over here? Yeah, it's a negative p, so we're going to do a plus p and a plus p. That cancels these guys out because those are opposite. Over here, p plus p is 2p. And then we still have the plus 4, and then it equals 2. Now I got my p's to the left, but now I need to get the numbers on the right. So I got to get rid of this guy. How do I do that? Yep, minus 4. Minus 4. Those will cancel. So now 2p equals 2 minus 4 is negative 2. And then we will divide by 2, so P equals a negative 1. We do okay? Yeah? We're good? So let's try it over here. Same thing, P's to the left, numbers to the right. How do we get this P over here? Minus P, minus P. Now over here, the P minus P cancel out. They're supposed to, right? But what do you notice over here? What's P minus P? They also cancel out at 0. So the P's over here are going to cancel out too. What's left on the left side of the equation? 4 equals, what's left on the right side of the equation? Negative 2. All right. This situation occurs every once in a while as we go through and solve equations. If all of your variables cancel out, what you have to look at what is left. Is that true or false? Does 4 equal negative 2? No. So then if 4 does not equal negative 2, then that means that this equation, this side, does not have a solution. Okay? There's no number you can put in place of these P's that would make this equation true. 4 does not equal negative 2, so this side of the equation has no solution. Does that mean that the whole problem has no solution? No. What's the one solution this one has? The negative 1. So this is another one of those situations where you only have the one solution. 14 versus what we have covered up to this point. Number 14, we have variables on both sides. This time we don't have absolute value on the right side. Okay? So we're still going to call this our absolute value. This is still going to be our distance. Distance may look a little funky because it's got a variable in it, but we are still going to call that our distance. So absolute value over here, distance over here.
So our right side is basically what is our distance?
Because of all the way these problems are set up, yes. Basically, you're just your absolute value. The one that's not your absolute value is going to be your distance. If they're both absolute value, just pick. One's absolute value, one's distance.
So then above it wouldn't have mattered?
It would not have mattered. We would have gotten the same solutions had we done this one as absolute value and this one as distance. Okay, good question. All right. So if this is our absolute value, is our absolute value isolated? Is it by itself on one side? Okay, so step 1's already done for us. What is our step 2? Separate it. We're going to make our two equations. So we're going to make that guts the 2x plus 12. And we're going to set it equal to a negative 4x. And then 2x plus 12 equal to a positive 4x. Okay, so again, using that distance twice, one with a positive and one with a negative. All right, we have variables on both sides again, but this time we only have a number on the left side, so I'm going to move my variable to the right. It's going to save me a little bit of work. All right, so minus 2x minus 2x. So that's going to leave me 12 over here and negative 6x over here. Divide both sides by negative 6. Those divide out. 12 divided by negative 6 is negative 2. Let's do the same thing on the other side. So again, moving 2x to the other side, minus 2x, minus 2x. This time 12 will equal 2x. Divide both sides by 2. And this time x equals 6. All right. Everything worked okay as far as the algebra was concerned? Okay. Do you guys remember how I was showing you earlier to check your work, check your answers? How do we check? Good, we're going to plug them back in. So let's plug in the 6 in place of the x. Everywhere there's an x. So actually we're going to put a 6 here and a 6 here. Okay, so what's 2 times 6? 12. What's 12 plus 12? 24. And then the absolute value of 24 is 24. Okay, so keep that number in your mind. That's 24 on the left side. We're going to put that same 6 right here. What is 4 times 6? Also 24. So did I get a 24 on both sides of the equation? Okay, then that one checks out just fine. That one's good. Let's try it over here with a negative 2. 2 times negative 2.
Negative 4.
We're multiplying. Would be negative 4. Negative 4 plus 12.
Negative 4 plus 12 is negative 8.
Positive 8. All right, negative 4 plus 12, positive 8. Absolute value of 8. What's the absolute value of 8? So how far is 8 from 0? 8. Okay, so this time we have an 8 on the left side. Keep that in your brain. 8's on the left. Take that same negative 2 and put it right here in place of x. What is 4 times 2? Negative 2. Negative 8. All right, I got a positive 8 on the left side. I got a negative 8 on the right side. Are those the same?
Well, no, but
Are positive 8 and negative? It's because of the absolute value. Okay, so negative 8 and positive 8 are not the same thing. You guys understand we got a positive 8 on the left, right? We got a negative 8 on the right. Are those the same number? No. Which one would you rather have in your bank account? Positive 8 or negative 8?
Positive.
I think so too. They are not the same number. This answer looks great when I go through and do the algebra behind it. But when you plug it back in, because we have variables on both sides of the equation, this is what we call an extraneous solution. The prefix, extra. So all the algebra looks good. We did not do anything wrong algebraically. But what happens when we have variables on both sides of an equation? Sometimes algebraically these answers show up, but when you plug them back in, because of the process of the function, in this particular case the absolute value function, the answer does not work. So down here under extraneous solution, I need you guys to write in an extraneous solution can happen. And I'm putting can. That doesn't mean it has to happen. Nope, move it. Okay. An extraneous solution can happen when variables, V-A-R-S, variables, on both sides of equation. EQ equation, we're okay with that? So when you have variables on both sides of the equation, you're going to go through and work it just like we did. We didn't approach this problem any differently. We're going to work it just like we have been working it. But the difference is we must check answers. Two situations you guys need to be heads up on when you're solving absolute value equations. The first one we ran into at the very beginning. Absolute value is a distance. So if the distance is negative, then what does that tell me? That is your no solution. Your second situation you need to be heads up about is when you have variables on both sides of the equation, you have to check your answers. Because what I'm going to do, I'm telling you guys in advance, what's going to happen is you guys are going to get a problem like this. I'm going to give you multiple choice. I'm going to say 6 is the right answer, negative 2 is the right answer, or they're both the right answer. Now, what's the actual right answer? Just the 6. Negative 2 is not a correct solution. Do we understand extraneous solutions? And that happens when there's variables on both sides. That's the only time that's going to happen. Now, I always suggest to check your work. Check your work on all of them, and then you don't have to worry about it, right? But sometimes when you have variables on both sides, you could get an extraneous solution. Any questions?